Hello and welcome. In this lecture, we will create a Spring Stripe service so that we can complete the user account creation journey for the Pro account user. Let me warn you in advance, this is going to be quite an intensive lecture, so please make sure that you have got plenty of time and that you are fresh and energized. The first thing we'll do is to ensure that we are pointing at the Stripe feature branch with the git command git checkout Stripe. Now, we'll head back to our Stripe account. If you have followed the lecture on how to set up Stripe, you should already have an account at dashboard.stripe.com. After logging in, I'd like you to click on the down arrow next to your username in the top right and select Account Settings and then on the API Keys tab. Then, I'd like you to verify that the content of the test secret key and test publishable key is the same as the one in your stripe.properties file under the user home.devops body folder. Then, in this file, I'd like you to copy the stripe.test.private.key and stripe.test.publishable.key properties as the same property names but replacing the word test with the word prod. The idea is to have two sets of Stripe properties in this file, one for test and one for prod. By now, you have probably guessed that the next step will be to modify the development config and production config classes so that when we run with the dev profile, we load the Stripe test properties, and when we run with the prod profile, we load the Stripe prod properties. I know that you are also probably wondering why we aren't using the real Stripe production properties for prod. The point is that I want to show you how to set up your project so that you can use Stripe, but I don't want to risk any one of you starting to use the live keys by mistake. Also, please remember to never share your Stripe private keys with anybody, especially the production ones. Now, we'll head back to the application config class and load the stripe.properties file. We can do this by adding another @properties source annotation and passing the stripe.properties file as parameter. Next, we want to define a bin of type string that contains the property value. The objective is to have a unique bin name but two different values depending on the profile that the application runs with. We can open the development config class and declare a string instance variable with name stripe_dev_key. We will use the @value annotation with value stripe.test.private.key. Then, we can declare a Stripe key method that returns the property that we have just declared. We will annotate the method with the @bin annotation. As a reminder, by default Spring assumes that the bin name is the method name, in our case Stripe key. We will do the same thing with the production config class, only this time we will use the stripe.prod.private.key value for the @value annotation. We can call the instance variable stripe prod key. The method will be identical to the one defined in the development config class, only this time it will return the stripe prod key property. The important thing is that its name must match the one in development config. Now we have a Stripe key bin that we can auto-wire when we please. Later on in this lecture we will auto-wire it in the Stripe service. Next, we will add the Stripe Java SDK dependency to the POM.xml file. The Maven group is com.stripe, the artifact ID is Stripe Java, and the version at the time when this video was recorded is 1.40.0. Next, we can have a look at the Stripe Java API documentation online. If you point your browser at https://docs/API?lang=Java, you will see the Stripe Java API documentation. We are interested in the core resources section on the left and particularly in the customers and tokens section. If you click on the customers link and then on the create a customer link, you will be presented with an API example of how to create a customer in Java. The only real information that we need is a Stripe token value, which we need to create before invoking this function, and a plan ID. So let's see how to create a Stripe card token. You can click on the tokens link and then on the create a card token link. By scrolling towards the bottom of the right panel, you will see a sample Java API to create a token. First, we need to create a map that contains credit card information. The information we need is the card number, expiry month, expiry year, and CVC. This is what in the sign-up form we have called the card code. We then need another map where to put a single element with the key named card, and as value, the map containing the credit card information. We then call the token.create method, passing the token parameters map as argument. Now, if we head back to the create customer example, we can see that there are various arguments we can pass to this method. For our use case, we want to pass in an email address, a description, a plan ID, which in our case is 2, and the token ID that we have just created in the previous step. By passing the plan ID to this method, Stripe will subscribe the customer to the specified plan. In the test plan that we have set up, customers will be billed $10 each month until they unsubscribe. Also notice that before any interaction with Stripe, we need to set the stripe.api key static variable to the private Stripe key that we have defined in the Stripe properties file. This is so that Stripe can first authenticate the application, but also can use the key to encrypt outgoing and incoming traffic. To recap, first we create a token with the credit card information, and then we create a Stripe customer with that token, and we subscribe them to Plan 2, which charges them $10 per month on a recurring basis. Let's start by creating a Stripe exception class under the exceptions package. We will use this class in the Stripe service that we are going to create in a minute, when an exception occurs while interacting with Stripe. The class is very simple, it extends runtime exception. Then, we can create a Stripe service class under the service package. As usual, we will annotate it with the @service annotation. I'm now going to copy this method implementation from the code that I've prepared for this lecture, and then I'll talk you through it. The code is pretty simple. We have auto-wired the Stripe key bin that we have declared both in the development config and production config classes. Then we have defined a single public method called the create customer, which accepts a map for the token parameters and a map for the customer parameters. As discussed, first we set the Stripe API key static variable. This is a mandatory step in the process. We then invoke the token create method, passing to it the map of token parameters. We then set in the customer params map a key with name source and as value the token ID returned by Stripe. Next, we invoke the Stripe customer create method, passing the map of customer parameters as argument, and finally, the method returns the Stripe customer ID. We can actually test this method with an integration test. We can create a new class named Stripe integration test under the integration package. I'm now going to copy the code that I prepared for this lecture and then I'll talk you through it. In the test, we auto-wire the Stripe service that we have just created and the Stripe key bin. Then, in the init method, we make sure that the Stripe key string is not null, and we set the Stripe API key to the Stripe key value. In the test method, we create a card params map with some bogus credit card information. Notice how we have set up the year to be the one from the current date plus 1, so that our test remains valid over time. Then, we set the card param map into the token params map with a key named card. Next, we create a customer params map and we set the description and the plan ID. The method then invokes the create customer method on the Stripe service and asserts that the customer ID has been returned. It then cleans after itself by retrieving the Stripe customer from the ID just received as a return value, and by invoking the delete method on the customer object. If we run the test now, it should go green. Theoretically, we could now head back to the sign-up controller and complete our journey, as it seems we have everything we need. Before doing so though, wouldn't it be nice to have a utility method that, given a pro account payload POJO from the sign-up page as a parameter, returns a map that we can just pass to the Stripe service create user method? This is exactly what we are going to create next. We can create a Stripe utils class under the utils package. The class will offer a single extract token params from sign-up payload method that accepts a Pro Account Payload Pojo as argument and returns a map ready to be used to retrieve a Stripe token. I'm now going to copy this class implementation from the code that I've prepared for this lecture, and then I'll talk you through it. The class is very simple. It declares the constants required by Stripe when setting a token param map, and then it creates the two maps with the values contained within the Pro Account Payload, returning the outermost map. We can also write a unit test to ensure that this method works as expected. We can create a Stripe Utils unit test class under the unit package. I'm now going to copy the code that I've prepared for this lecture, and then I'll talk you through it. Here, we create an instance of the Pro Account Payload Pojo and set the credit card details, using as values the constants that we have created in the Stripe Integration Test class. Then, we invoke the utility method that we have just created and verify that the returned map contains all the expected values. For the assertions, I'm using AMCREST, which is a test framework that is available to the application thanks to the Spring Boot configuration. If we run the test now, it should go green. Now, we can head back to the SYNAP controller to complete our journey. First, we'll need to auto-wire the Stripe service that we have just created. I'm now going to copy the code that I've prepared for this lecture, and then I'll talk you through it. In the code that I've pasted, we have filled in a token param from the Pro Account Payload Pojo by invoking the Stripe Utils utility method that we have just created. Please remember that this happens only if this is a Pro subscription. Then we create a customer param map with a description, an email address, and the plan selected by the user. For the description and email, we use the information contained within the Pro Account Payload Pojo. For the plan, we choose the value that is contained within the selected plan that we have retrieved earlier in this method. We then invoke the Stripe Service createCustomer method with the two maps and store the Stripe customer ID in the user entity before saving it to the database. If we run the application now and go through the Pro Account SYNAP journey, we will see how it all comes together. Make sure to run with the dev profile so that we can access the H2 console and look at the user record. There is a lot more that can be done with Stripe, like managing plans, executing one-time charges, and so on. For a full list of features available through the API, please refer to the online documentation. The last activity we need to do is to close the Git flow workflow. First, we push the local code remotely with the git commands git add *, git commit -m completed the Stripe service, and git push. Then, we merge to the develop branch with the git commands git checkout develop, git merge Stripe, and finally git push. This lecture completes this section and the user sign-up journey. In the next session, we will prepare our environment for production before delving into Amazon Web Services and on how to deploy highly scalable and highly available applications onto the cloud. Thank you for your time, and I see you in the next lecture.